G'day Bifrosters, we're back to this. You remember this? This is the for each loop we did yesterday. Yesterday? Yeah, I think it was yesterday. It's the for each tutorial anyway. So now we're going to do it again, but we're going to do it a different way. We're going to do it with the next kind of loop, which is an iterate loop. So let's put one down. Now the iterate loop works an awful lot like the solver, and if you wanted to see how the solver worked, you can pop over and have a look at my solver tutorial. I'll link it in the description if I remember. But here's what we're going to do. We're going to just repeat this. So what this does in here is it multiplies the current index by 3, uses that to translate some points, and then distorts them with a field. So we're going to do something really similar in the iterate loop. So for that, we'll need the sphere going in. We got that. And we will need a value of 3. So what the iterate loop does that is different is it allows you to, for a start, it's not parallel. So it runs in sequence, which means I can have an increasing total here. So I can run it through once, and then I've got a value, and then run it through again and add something to that value, and run it through again and add something to that value. So just like the solver does. So to facilitate that, let's make a couple of ports just with this value node, which we will then delete. And it kind of does not like that very much, but that's okay. We'll fix that. So we've got 2 float ports. And I'm going to use the float ports to translate. So whereas before I multiplied this by the current index, which I could do here as well, and that would be fine. This time what I'm going to do is I'm going to add it to this value. So let's just rename this to translate in and translate out, like that. Great. So translate in comes in, and we throw down an add, and we're going to add this 3 value to it. Then once more we need another value that is a vector with 3 components, and this time I'm just going to get a little smart. In the y I'm going to put down a minus 0.5. Pop this guy into the x, so this is going to be incrementing. Remember this, we did this by multiplication last time. We multiplied the current index by 3, so that as that index went up and up, that number went up and up, and these went along and along. So this time we're going to pop that into the translation, and then we're going to output the points, but we're also going to output this. Let's get this out of the way for now. Now, at this point in time, this won't work because I need to tell the iterate loop what it's doing. So for that, I'm going to set a port state. I'm going to set the port state. You can see that it's showing me the 2 inputs here, sphere mesh and translate in. I'm going to set the port state to translate in, or translate out to translate in. So what this does now is very much like the solver. Very, very much like the solver. So this is a value coming in. The first run through the loop at 0. I believe, so we get 3 plus 0 is 3. That goes off and translates this guy, but it also goes out to the port. And so the next time through, so current index is now 1, it was 0, it's now 1. The next time through, this should be 3, it gets 3 added to it, should be 6. So let's see if that worked. So first off, this is having a little bit of a problem because it's got no iteration target. It doesn't know what to run the loop over. To fix that, I'm just going to set this to the iteration target, and we'll plug this in here. And maybe just back in here, we will make this a bit bigger, -2. So you can see what's happening here. Here's our top line, that starts back there. This one starts 2 across. It's still got the same number because it's still got the same number of max iterations. That's 10, but it's displaced a little more. So if I wanted to start this at a certain value, I feed something in out here. So grab that there. Let's start with -3, perhaps, and we'll feed that in out here. You see that move back? because it's starting at -3 and then it goes to 0 and so on and so on and so on. So that's a good way to have a start value and then have that value climb. Let's just match our other one so we can make it look a little bit prettier. So we're going to do a displace points. And we're going to use the same system again, just so you can see what's going on. We'll pop that in there and that in there. This is still iterating through here. This is just displaced with its own normals right now. So don't worry about that. And I'm going to need a curl noise field, like we had last time. We'll plug that into there. So you see it's doing the same thing. They're moving through the field. The field isn't changing. But I'm going to basically do this again. So I'm going to grab this value here. I'm going to change that to 1. I'm going to make one port here, one port here, and it's going to basically not enjoy itself very much. We're going to change that port type to float, and we'll call this displace out, and you guessed it over here, displace in. And we're going to do exactly the same thing here. I'm going to attach that to our displace in, attach a 1 to it, attach this to displace out, and then we'll set up our port state like that. Now it's all working. This is not doing anything but incrementing right now. And what I'm going to do is I'm going to take the max iterations, turn that into a float like this. So the max iterations is the number of times through the loop it goes. And then I'm going to divide this number that we're iterating up. I'm going to divide that by this. So what this should get me is a number between that starts very low and climbs up to eventually be 1. And then we'll plug this into the weights, and there you go. So again, it's starting at 1, but it's getting higher and higher and higher as it goes, and you can see this is displacing more and more and more. If I wanted to, I could again take this, we'll start this at -1. This might break because I'm not sure if you can have negative weights. Nope, that seemed to work. So now that's got 0 weights, and that should have 1 weights. So that's iterate. It's the same as for each, except it's not parallel. It runs over and over and over, sort of linearly. So you can't do several things at once like you can here. And it iterates something coming through. In this case, I'm iterating a translate and a displace. And if you think about how the solver works, this is really, really similar. Okay, so that's the quickie for iterate. I hope it's helped, and I'll see you next time. Thank you.